Given a matrix of ones and zeros, all ones form land and zeros form water. Additionally, two pieces of land are connected if they are adjacent in one of the four cardinal directions: up, down, left, and right. We have to find the total number of islands present. This problem can be broken down into two pieces. Number one, starting from one piece of land, we want to discover all the pieces of land that it forms an island with. And number two, traverse through the matrix and do this for all pieces of land we have not discovered yet. To fully understand why we need to do this, let's take a look at an example. Note, I've added a stack for better understanding. To identify which element I'm putting in the stack, I'm adding its position in the matrix. Starting from the first position, we've discovered a piece of land. Now, as per step 1, we discover all pieces of land that it is connected to. We do this by checking for land left, up, right, and down. The only connected piece is below us, so we add that to the stack and repeat the process on it. This time, we have a connected piece above us, but wait, we've already visited it. So how do we ensure we don't end up in an infinite loop and keep track of the nodes we've visited? It's simple. Let's create another matrix of Boolean values. So before visiting a new node, we'll all check if it has been visited. If not, we go ahead and mark it as visited. This way, we can discover an entire island and increment our total number by 1. Moreover, the visited matrix will allow us to iterate over the graph and repeat this process for all unvisited land, because now we know if some piece has been visited or not. Let's code. We'll start by adding some checks for edge cases. If any of those cases happen, we return 0, initialize the rows and column length, and the number of islands that we are going to return. We got to initialize the state of our visited Boolean matrix, by which we know which nodes we have visited, and then traverse through the entire matrix that we have as an input, and check to see if the current position we are on is a piece of land, as well as we have not previously visited that land. If that happens, then we need to discover the entire island that we have not yet discovered. For that, we're going to write our own function. Let's call that discover island. This function is going to take the grid, the visited matrix, and our current position in the traversal as the input. The most important thing we have to do here is mark our current position as visited so that we don't come back to it and avoid the infinite loop. We then initialize a delta x and a delta y array that allows us to loop through all our neighbors instead of doing a for loop with a bunch of if statements. This makes it look a lot cleaner. Now the only thing we have to do is loop through 4 times for each neighbor of the current element and find what the neighbor's indices are. So we have a new row and column variable, which is essentially for each iteration of the loop, the row and column of the neighbor. And now, if the new row and column that we have gotten are within the bounds of the matrix, and the neighbor is indeed a land, as well as we have not visited that neighbor, all we want to do is call the discover island function again on that neighbor, so this recursively it discovers the entire island. We don't have to return anything from discover island because all discover island is doing is changing the state which is in the visited matrix, which allows us to know all the nodes of a particular island that have been visited. The time complexity for this is going to be m times n, essentially because we traverse through every single node, and the space complexity is going to be m times n as well because of the visited matrix that we created. There you have it, guys. This is a number of islands. It is not bad at all. Try and practice this a couple of times and I guarantee you'll get the hang of this. If you have any questions, put it in the comments, like and subscribe please. That is extremely helpful for me, and I'll see you in the next LeetCode video. Goodbye.